Hi everyone, I'm Ham Acero and today I'll talk about the automatic water level controller. This system automatically turns the water pump on or off depending on the water level in a tank. I chose this topic because it's practical and commonly used in homes. It saves water, electricity, and prevents overflow. The water level controller works as a feedback and control system. It uses sensors to continuously monitor the level of water inside the tank. When the water drops below a certain point, the sensor sends a signal to the controller, which then activates the pump motor to start filling the tank. As the water level rises, another sensor placed near the top detects when the tank is almost full. It sends a feedback signal back to the controller, which turns off the pump to prevent overflow. This process keeps repeating automatically. The system checks the actual water level, compares it with the desired level, and makes corrections whenever needed. This is an example of negative feedback, where the system reduces the difference between the actual and desired water level. In short, the controller doesn't just run blindly. It listens to the sensors and reacts based on feedback to maintain balance and stability in the system. We can represent the water level control system using this simple block diagram. It starts with the set water level, also called the set point, which is the desired height of the water. The comparator checks the difference between this set point and the actual water level measured by the sensors. That difference or error is sent to the controller, which decides how much the pump motor should run. The actuator or the pump then adds or stops the water in the tank, changing the water level. The level sensor measures the new level and sends it back as feedback to the comparator. This creates a continuous feedback loop that automatically adjusts the pump's action to keep the water level close to the set point. The goal is to minimize the error between the desired and actual water level, showing how feedback maintains stability and control in the system. Now, let's look at the simple automatic cycle that saves both time and water tank with two sensors. There's a lower sensor near the bottom and an upper sensor near the top. When the water level drops below the lower sensor, it sends a signal to the controller that the tank is empty. The controller responds by turning the pump on and starting the filling process. As the tank fills, the water eventually reaches the upper sensors. These sensors send a feedback signal to the controller, saying the tank is full. The controller then turns the pump off immediately. This automatic process repeats every time the water level changes. It's a perfect example of negative feedback. The system continuously checks the water level and adjusts the pump's action to keep it within the desired range. If built using a microcontroller like Arduino, it would act as the brain that makes these quick control decisions based on the sensor inputs. From this system, I realized how feedback and control are applied even in the simple home automation. Sensors, controllers, and the actuators work together to maintain a stable system, just like in large industrial control systems. So, this project shows that control principles are everywhere, saving resources, improving safety, and making everyday life more convenient. Thank you for listening for my project. I am Hamasero. Thank you.